This example is going to talk about the multi-objective decision making, and we are about to find out the Pareto optimal front. So far, the examples that we have analyzed with each other are all referring to single objectives. So we had one objective function that we wanted to minimize it or maximize it and find out the optimal decisions variables. And as you can see on this plot, suppose we want to maximize two different objective functions simultaneously, and there are some solutions found as you can see on this graph. So if I show you another solution on this space, the blue one, the dark blue one. So if I look at these solutions, there are 5 solutions you can see here now. If I want to compare these solutions together, I can say that this solution is better than the dark one because it is better than the dark one in terms of OF1 and OF2, and it has better solution in every aspect. Okay, and also the white one has bigger OF1 and OF2, but the green one has a bigger OF2 but smaller OF1. So I can say that this solution can be dominated by this blue one and the white one. So if there is any solution that can dominate this guy, then we have to eliminate them. Another solution, consider this one. Now if I want to compare the red one and the orange one, which one is dominating one? The red one. The red one is dominating the orange one. Okay, so now I hope you understand the meaning of domination. So if I ignore these two new solutions that I showed you and just look at these 4, these solutions are not better than each other in every aspect. So if I improve one objective function, I'm deteriorating the other one. So the question is, how can I, if I have a problem with 2 different objective functions, how can I find out these Pareto optimal solutions? So but before I proceed to the coding and everything else, I want to ask you, why do we need multi-objective optimizations? So can we combine the objective functions and then solve the augmented one in one shot? For example, let me give you another example. So you want to build a production plant, and there are some costs associated with that construction. There are some operating costs, there are some investment costs. So you can easily do the summation and then ask your decision making tool to find out the best decision for you. Okay, but sometimes the objective functions cannot be added together. They are from different dimensions. For example, one of them is environmental, for example pollutions, and the other one is cost. Some people say that the environmental aspects can be translated into cost. Sometimes it's true, sometimes it's not. Or there are some other aspects, for example the beauty of something and the cost of something, you know. So these two cannot be added together because the dimensions are different. Or sometimes these are costs, but both of the objective functions are cost or benefits or whatever, financial. But the size of each is completely different with the other one. So the order of magnitude is not at the same level. So optimizing one of them is not putting any effect on the other one, you know. And sometimes the objective functions are the same. For example, they are both cost, but 2 different people are going to pay them. So adding them together and minimizing the total cost is not always beneficial for both. Okay, so we have to find out some set of solutions, some set of non-dominated solutions, and give them to the decision maker and ask them to choose. And there is another thing: if we go with the weighted sum approach and add the different objective functions using different weights, then we will find out just one objective function and one set of decision variables. Okay, and what happens if that weighting factors change? So we have to run the optimization again. Okay, but now we want to find out the set of solutions, as you can see here, those that are connected with dashed lines, in a way that if your weighting factor change, you can change your solution. It's not needed to run the program again. And also you can see that if you move toward any of those objective functions, what will happen to the other one. So if I am at the orange solution, if I want to go to the blue one, for example, improve it in terms of OF2, I want to increase the OF2, this is how much I will lose in terms of OF1. Okay, so for simplicity, consider this very easy example. There are two constraints. OF1 is something, OF2 is something else, and the range of variation for x1 and x2 are also specified. Okay, so let's have a look at the Python code. I import the required packages. Sometimes some of these packages are not really necessary, but there's no harm if you keep them right there, because maybe you need them in the during your coding. So I specify the range bounds of x1 and x2. You can see it here. They are both non-negative reals, and also there are two objective functions, OF1, OF2. They are defined as variables. And also equation 1 is something, equation 2 I will explain it later, and equation 3 is the other equation. So what is equation 2? Equation 2 is telling us that OF2 is less than something. Okay, so in order to solve that problem, just let me show you something else on the slides and then come back to the points. So if you look at this graph, and if I want to for example maximize the OF1, what will happen? What is the obvious solution for that? The obvious solution is here. Okay, but and every time you just maximize the OF1, which is the capability of the Pyomo package, you can only maximize or minimize one objective function, okay, at a time. And if you want to maximize OF1, this is the solution that you will get. Okay, but in order to be able to not trapping it here, we add another constraint for OF2. I can say OF2 should be bigger than something, or smaller than something, and then solve the problem. So I change that limit for OF2 and then try to optimize the other one. I could do it for the other objective function, the OF1, and I could say, okay, the minimum value of OF1 or maximum value of OF1 is something. Now optimize the other objective function. But how can I write it down in Pyomo? So this is the constraint I was talking about. So I will limit the OF to less than something, and I will change that limit, okay, iteratively, and ask the Pyomo to solve it. So as you can see here, it's strange. I do have more than one objective function. That's fine in the definition phase, but when I want to solve that, I have to deactivate one of them. Okay, so I put a limit for OF2 and I deactivate objective 2. Okay, pay full attention here, and then I ask the Pyomo to solve it. So what objective is being optimized? This is the active objective. the objective 1, which is OF1. So it is solved. In this way, the maximum value of OF1 is found. Okay, and how much is the epsilon at the beginning? It's a very big number, you see. So actually there is no limit happening here. But next time I will deactivate objective 1 and keep the objective 2 activated, and then resolve the problem again. So look at the objective functions. The first time the objective function 1 is its maximum value. Second time objective function 2 has its maximum value. Okay, so the range of that Pareto optimal is found, and the x1 and x2 are found. But how should I continue? I have to do something about that limit I already specified here, the epsilon. Okay, so if I am talking about the OF2, I should look at the variation range of OF2. It is changing between 0.2 to 9.58. So I can say it can start from this quantity and go down up to here, and then try to optimize the other objective function. Okay, so look at here. At each point, I write down a for loop, and at each iteration I am updating the value of the epsilon. So at the first iteration it is minimum OF1, okay, and at the final one it becomes a maximum OF. Okay, so in this way, when I solve the problem and optimize it, I can easily find out the value for the other objective function. So if you can see here, I am starting from 0.2, and little by little I'm increasing this epsilon, you see, and try to optimize the other objective function. Okay, and if you want to graphically show it, you can see it here. Okay, so the number of points depends on the how many steps you have specified for your programming. Okay, and that's it. Thank you very much.